The loop statement is great for looping through all the records of our table. But there is another statement we can use to access the records of an internal table. This statement is called the read statement. And this statement allows you to specifically read individual records from a table. So in our case, because we are using a header line, when we use the read statement, the record will be read into the header line of our internal table. When you use the read statement in your program, you've got to be aware of how your internal table has been declared, because that will affect how you write your read statement code. And what I mean is, what type of internal table are you working with? Is it a standard table, hash table, etc.? If you're working with a standard table with a non-unique standard key, then you would write the read statement like this. Read table, then we specify the table, which is itab01, and we can specify the index number. This means we're reading the 5th record of our internal table into our header record. The beauty of using the read statement is it is the fastest way to access the records of an internal table, and using the index specifically is the fastest form of this read statement itself. This type of access is about 3 times faster than using a hash algorithm, which, as I've mentioned previously, is our best performing internal table when dealing with lots of data. As well as being 3 times faster than a hash algorithm, it can be up to 14 times faster than using a normal table key. But the problem is we don't always know what the index number of the record is that we want to read, and that's why we nearly always end up using table keys. So let's add an internal table to our code and define some key fields as our table key. So the way we write a read statement using a table key is, again, read statement. I'll tell you what, I'll pretty it up. Oops. Okay, we have read table, then we specify our table name, but instead of using index and then the index number, what we do is type with key, and then we specify our key fields. So I just go onto a new line, and we'll indent it a little bit, and because our itab01 is made up of these fields up here, we will say our key field is employee. So we would say employee equals, and then we specify an employee number. Simple as that. You are not just limited to using a unique key. You can use other fields as well, but the problem there is that it is difficult to know exactly which record you will be reading. Because let's say if we use the surname field and we add 3 people called Smith, well, you wouldn't know which record has been read. Is it the 1st, 2nd or 3rd? Well, with a non-unique key, the read statement reads sequentially through your table, so actually you'll get the first record that appears in your table that matches your key. But again, you won't have a clue if there are any more records that match without adding extra code to carry out some extra checking. You know, such as check to see if the record was found. If it was found, read the next record. And again, see if that record was found. You know, that type of thing is the only way you'd know if there are more records with the same key. Now this read statement we have just seen can also be used for sorted tables and hash tables. When you specify the key fields to use in your search, the system will run a binary search for sorted tables and use a hash algorithm for hash tables. If the fields you choose to use are not key fields, the system will carry out a sequential search for both the sorted and hash tables.